To educate producers and the public on the close relationship between growing cover crops and healthy soils, the Langdon Research Extension Center hosted the 2014 Cavalier County Soil Health Tour in coordination with the local NRCS, Cavalier County Soil Conservation District, and Cavalier County Extension. The tour included visiting the Cron Farm, where cover crops were successfully established on a saline sodic area. At the Langdon REC, tour participants were given a demonstration on how to manage good and saline sodic grounds by planting water use efficient crops and salt tolerant grasses. Additionally, 3 strips of different cover crop mixes were compared for their growth patterns on a saline sodic gradient. As a demonstration, 2 soil pits were dug in sites that exhibited good and saline sodic soils. The tour concluded with a demonstration of the NRCS rainfall simulator, which showed surface runoff differences between no-till and conventional till soils, and soils with and without a cover. Speakers included Ron Beneda, Randy Melhoff, John Lukacs, Chris Augustin, and Naeem Kalwer of NDSU Extension, and Craig Brumbaugh and Dustin Brodina of Natural Resources Conservation Services. Morning coffee, donuts, and a noon meal were sponsored by the Cavalier County Soil Conservation District.
We're going to talk to Naeem Kalwer, and we're looking at some cover crops in some different mixes today. And it's really important to know the condition of your soil, the salinity of your soil, before we put the cover crop down, because some will do better than others.
Yes, you're right. Cover crop range from sensitive crops to salt-tolerant crops. We have to know our soils first before we go for a mix. For example, turnip and radishes would be very good at making deep roots into these soils, but they may not be very salt tolerant. Beets, barley, and oats, what we found today, are more salt tolerant than turnip and radishes. So depending upon the soil type and how high the salt levels are, then we'll go for a mix which would work best for that kind of a soil.
And the simple fact of the matter is, we were in a spot today where the water is going downhill. There is some salinity at the bottom of that slope, if you will, and you could see the gradient as we went down the cover crops, and it made a big difference.
Yes, like it was a combination of high ground plus low ground, and high ground generally would not be high for salts because they have good drainage and the water moves laterally into the low grounds, and the low ground didn't have any further drainage. So that means there would be high water table depth, which will lead to the accumulation of salts and sodium. And that was the case. The low ground you saw today was very high for salts and sodium. We have this soil analysis report too. Now that was the kind of a ground where even barley won't do good. That's when we go to the native prairie grass varieties, like for example tall wheatgrass, slender wheatgrass, intermediate wheatgrass, AC saltlander, which is a green wheatgrass, and Russian wild rye, that kind of a combination. These grasses may not be very water use efficient crop, but at least we will get something going there, because those low grounds are the saline areas. If we leave them bare, it'll make the situation worse. By planting these crops or grasses will provide soils of vegetative cover. These grasses will use up some water. They'll provide plant biomass, which will add to soil organic matter. That'll result in better soil structure and drainage.
And that's kind of something we saw too with the soil pits on either end of that, just the differences in the soil, and that's what's causing the differences for the cover crops surviving well, I guess, is it?
Mostly the soil type was the same. The difference was that on the high ground, the excess water was draining from that soil, but it was all getting dumped in the low ground, and it was all about the water movement. And when this water would come close to the surface, it resulted in the accumulation of salts and sodium, and that's what made that ground saline versus the high ground.